Hi, this is a quick demonstration of how to use syntax highlighting in NeoVim so that when you edit a program in TTP-ASM, the editor can help you spot certain problems like visually and right away. So the first thing is you want to download and install NeoVim, and I believe it is compatible with most operating systems. So if you click on install now, it will bring you to the link where you can go ahead and download different versions. So you can have you can use the Windows version, or if you use Mac OS 10, or if you're using Linux, there are various ways to install it in depending on the distribution. In Debian, NeoVim is a package already, so you just have to install the package, and I believe that is the case for most operating systems. It is already a package. It just depends on which distribution you're using, and the method is slightly different. So that's the first step. And then the second step is to take a look at a few files. So I only have this working in Linux. I believe in Mac OS 10 is about the same, but in Windows it will be slightly different. There are two files that you need to quote unquote install, which basically is just you copying and pasting into a specific folder. In Linux, the folder is located in right over here is tilde slash dot config slash nvim. Oops, I did not mean to vim that. Okay, so let's just cd over there. And there are two files. One file is called file type.vim. The init.vim, is for initialization of NeoVim. So, if you want to use mine, that's fine. Okay, if you want to use the default, that's fine. I don't think that is needed for this to work, but you definitely need file type to work. Okay, so if I look into file type.vim, all it really is to turn on extension detection. So any file that has an extension of TTP-ASM will have the file type set to TTP-ASM, and that is what triggers syntax highlighting for TTP-ASM to occur. Okay, and then if you look into the subfolder called syntax, it has a single file called ttp-asm.vim, and that is how the syntax is actually defined. So these two files are the ones that you need to include or to put into the folders, inside of your distribution. In Windows, instead of using .config, you use appdata/local to find all the configuration files for NVim. So you can also look up on the internet to see how to do that. So there's a page right here. Let me just copy and paste the link here so that you can see it in the recorder. There we go. So if you look this up and you just look for app data, this shows you where the default files are located. Now they use this to illustrate where init.vim is located. But if you can find init.vim, okay, let me switch back to the command line here. If you can find init.vim, that is where file type is supposed to go. Syntax as a subfolder usually does not exist automatically, so you will have to create the subfolder called syntax, and then inside syntax you want to put ttp-asm.vim as a file. So that's how you set it up. So the next question is, why do you want to waste your time to set up something like this? So let me just kind of illustrate what that can do. Okay, so I'm going to create a new file. Let me remove the existing test file, and we'll go ahead and create a new one. So nvim test ttp-asm, and once again the mechanism is triggered by the extension of the file, so you have to use ttp-asm as the extension in order for this syntax highlighting tool to work. So once you get in, you can now start to type. So comments are in italic. Okay, so comments are in italic, which is a fairly typical standard used by a lot of IDEs, integrated development environments. So that's hardly surprising. You can define labels. Okay, so let's go ahead and type something that we usually do. So as you type, it will do syntax highlight, syntax checking and highlighting at the same time. So when I type no op, you can see, if I just type no without the p, it is telling me that this line is no good. Okay, anything that is quote unquote highlighted in red is no good. But as soon as I finish the p, it is okay. And you can basically just continue with the comment, and all of this stuff is working. And you can say this is for the command line interface mode to work. Okay, and then you can use a JMP I to main. So let's just say that we make a mistake here. Instead of JMP I use JMP. So JMP by itself is highlighted in red because JMP needs to be followed by a register. But if I make a mistake here, instead of using JMP I and I use JMP and I say JMP to main, it continues to highlight that line because it knows that with JMP you can only have A, B, C, or D as the operand, but with JMPI you can use main. So if I go back and fix this and use JMPI, then JMPI as a mnemonic is bold-faced, and then main as a label is not bold-faced but using the same light blue color. Okay, so I can now go to main. Okay, I define the label. Label definitions are automatically highlighted in yellow because they are actually quite important. Okay, and once again, we can have a halt instruction here, so I'm not really making a big, huge program here. But if you supply anything other than, because the halt and the no op instructions are the two opcodes that do not take any operands. It doesn't need a register or nor an immediate operand. So if you supply anything that it is not needed, like give it a register A or a particular label name, it's got to highlight it in red because that is not correct. Okay, that's not the correct use of that particular mnemonic. So the syntax highlighter is actually sensitive to the mnemonic that you're using. Depending on which one you're using, it will detect an error. Well, okay, certain errors can be detected and other errors cannot, but it will try its best, without using a symbol table to detect errors. So let me show you what I mean by that. Okay, so typically we want to use a subtract instruction or a LDI instruction to initialize the stack pointer. So you can use a LDI. So without specifying the two things that an LDI instruction needs, it's going to highlight the LDI and say this is not okay, this is not done yet. Okay, so you can say LDI A with LDI D with 0. Okay, so that completes what LDI is supposed to do. So that's why the syntax highlighting is off. Okay, excuse me, the error highlighting is off. Okay, so because it's recognized to be okay. So if your 0 is some expression like 0, 0 plus, which is 0 plus 0, which is just 0, it's still okay. Okay, not a problem because an immediate constant can be any type of RPN, reversed Polish notation. So that's still okay. So typically we use this method to initialize the stack pointer. But we also have a different way to initialize the stack pointer, which is a slightly more efficient, which is using the subtract instruction, subdd. So you can do it this way too. But if you use subdd and you misspell one of the registers as E, it's going to choke on it. Okay. If you supply only one register, it's going to choke on it. If you specify comma but forget to specify the second register, it's going to choke on it. So it is actually doing syntax checking as you type, which can be very handy when you are writing a new program, especially you want to be able to detect syntax errors as soon as possible when you are editing. Okay. Okay, so let's check out some of the other stuff that this can detect. The decrement instruction. Okay, the decrement instruction only takes one single operand. So if you use decrement D, which is allocating 1 byte on the stack, it's okay. But if you say decrement comma 1, it's not okay because this is not recognized. Okay. The subtraction instruction is the same way. If you say subtract 1 from D, it's not going to be okay because it knows the second operand has to be a register and it cannot be an immediate. Okay. So let's continue with this. Okay, so I can say LDIA with initial value, which is a label that is supposed to be defined to be the actual value that I want to put into a local variable. And you can see that this error cannot be detected. In other words, if you refer to labels that are not defined, or if you define a label multiple times, if you have duplicate definitions of a label, the editor cannot detect it because the editor is really working on a line by line basis. So it can only detect patterns that I can specify on a particular line. To find out that a label is or is not defined, or it is defined in, there are duplicate definitions, I need to make use of a symbol table, and I'm pretty sure there's a way to do it in Vim scripting, but it is currently not done. So that feature is missing for the time being. Um, all right. So other things that is worth mentioning is if you use a instruction, it knows the first one is supposed to be parenthesized and the second one is not. Okay. So if you forget to parenthesize the first one, it will give you a syntax it will give you an error indication. If you use parentheses on the second one, which is also incorrect, it will still give you an error. Okay. If you use parentheses on the first one, then it will turn off the error highlighting. But if you say, well, I don't need to go to exactly where D is pointing to, just one byte past it, and you say D plus 1, which is not a valid way to specify that operation, it will still highlight it. So it is actually pretty good at detecting certain errors in the program. And as I said earlier, it just cannot detect issues with that can only be detected using a symbol table. So that's pretty much the only thing that it cannot deal with. Um, so I think this is all the demonstration I want to go through. Just to let you know that this is now available. The syntax highlighting uh, specification is now available, and I believe that specification will work on regular Vim as well. So you don't need to use NeoVim, but if you use regular Vim, you have to basically change the placement of the files that I just talked about, which is file type.vim and ttpasm.vim, and you have to copy those files to a location that is specific to Vim. NeoVim has a different path for those particular files. So that's it. Okay, this is just a super quick. You can call it advertisement. You can call it demonstration. You can call it an announcement of a tool that some of you may find useful. Okay, I personally find this really useful, and that's why I worked on it. So this way, if I make a stupid typing mistake when I'm editing a program, I can detect the problem right away in the editor without having to copy and paste it into the assembler first. So that's I would say, minor improvement in terms of workflow, but it is still an improvement. All right, and I will talk to you guys sometime later today in the lecture.